Now the 24th question. A die is thrown twice. What is the probability that 5 will not come up either time, and second one 5 will come up at least once? Once again, a die is thrown twice. What is the probability that 5 will not come up either time, and second one 5 will come up at least once? The experiment is throwing a die twice, and we know that the sample space is 1 1 1 2 1 3 etc. up to 6 6, and we are very sure that n of s is equal to 36. Number of outcomes in the sample space is 36. There are two parts for the question. First question is to find the probability that 5 will not come up either time. That means in both the cases 5 must not be there. We have to collect the number of elements in the sample space in which 5 is not there in two outcomes. And in the second case, 5 will come up at least once. At least once means minimum one time. It can be one time, it can be two time, it can be three time, and it can be any number greater than 1. According to the question, at least one means either it can come in one die or it can come in both the dice. So in the first case, 5 must not be there in both the dice, and in the second case, 5 must be there in at least one die. So we will deal with the first part. To find the first part, we have to take the events in which 5 will not come up in either die. So here 5 is not there in both the events. Here 1 5, there is 1 5, so we have to avoid that. Again 1 6 is there, 2 1, 2 2, 2 3, 2 4. We have to avoid 2 5 because 1 5 is present. 2 6 is there, 3 1, 3 2, 3 3, 3 4, 3 5 must be avoided. 3 6 is there, 4 1, 4 2, 4 3, 4 4, 4 5 is avoided. 4 6 must be there. 5 1 is avoided, 5 2, 5 3, 5 4, 5 5, 5 6, because all these elements contains 5. Again 6 1 is there, 6 2, 6 3, 6 4, 6 5 must be avoided, 6 6. So these elements which are ticked will be there for this numerator. Why? Because the numerator we have to take the number of outcomes in which 5 will not come. Okay, so how many ticks are there? If we count the number of ticks, there are 25. So if we have to find the required probability is equal to number of favorable divided by total. Number of favorable means we have to count the number of ticks, because we have selected the tick by according to the question in which 5 is not there in both the dice. So number of favorable outcomes is 25 divided by 36 is the total number of outcomes. So in all these ticks, the total number of ticks here is 25. 25 means the number of elements in which 5 is not coming up in both the dice, both the cases is 25 divided by total number is 36. And for the second case, what we have to do is we have to find the number of elements. For finding the numerator, we have to find the number of elements in which 5 come up at least once. 5 come up at least once means either 5 can be in one die or 5 can be in both the dice. So we have to take this one, 1 5, 2 5, 3 5, 4 5, 5 1 can be taken, 5 2, 5 3, 5 4, 5 5, 5 6, and also 6 5. So 1 5 is there, 2 5, 3 5, 4 5, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, and 6 5. So how many are there? 1 2 3 4 5 6 7 8 9 10 11. So the required probability will be 11 divided by total number of outcomes in the sample space is 36. How we got 11 is we have to find the probability that 5 will come up at least once. That means we have to get a 5 in either one of the dice or in both the dice. At least once means at minimum 1. It can be 2 times, it can be 3 times, any number of time, minimum 1 time. So we have to take 1 5, 2 5, 3 5, 4 5, because 1 is there, 5 is there 1 time. Again 5 1, 5 2, 5 3, 5 4, 5 5 can also be taken. Why? Because in the question it is given that at least once. Again 5 6 and 6 5. So the total number of favorable outcomes is 11, and the probability value will be 11 by 36.